Okay. Let us look at problem number 7. We will jump to problem number 7. The other problems, the solutions of which may be available otherwise. In problem number 7, you can see that there is a bent pipe over here through which fluid is flowing. We are asked to find out, we are asked to draw the free body diagram for this. This bend is otherwise attached to pipes over here. Okay. Now, we will do the same exercise that we have done earlier as far as drawing the free body is concerned. Here free body has to do with locating what is the free body for which, what is the body for which I have to draw the free body diagram. In this particular case, let us choose to have only the pipe without water as the free body diagram, for the free body diagram, in which case I have to consider several interactions. One interaction that is commonly there is the interaction due to the weight of this the mass of this particular pipe with gravitation, which is let us say mg. The other interaction is due to the other pipes joining with this bend, right, which is over here. So, if I fix the, let us say, bottom pipe and ask the question, can I move this particular bend left, right, up, down or rotate, the answer is I can't do any one of them. Okay. In which case I can draw the resultant, let me draw it using another color. I can draw the resultant forces. Let us locate this point as let us say A. I am deliberately using, I am clubbing the entire surface of this into one single point. Okay. This is AY. There is also due to horizontal restraint, which is AX. Apart from that, it is not let to rotate because of this pipe, and therefore there will also be M at A. Now the question is, should I draw like this or should I draw like this? That is the question. The answer is you can draw either way, it is a matter of convention that you use. Generally we introduce a reference set of directions, let us say, so that it is easy for us to represent most forces in this type of fashion. Okay. So, in this particular case, whichever is an unknown force, I will use the direction which are positive in this. Okay. And as you can see, anti-clockwise direction here can be taken as positive for moment. Okay. In this case, and that is the reason why we have used MA in this direction. Okay. Similar is the case if you take this particular point where I will have an interaction like this, which is similar to this, except let us say this point is B, I will have a By, Bx and M at B, where M at B is the couple acting on it. So, we have finished interaction with the pipe down below, we have finished interaction with the pipe to the left, we have finished interaction with respect to gravitational force. So, we have removed all those. What is left now is the interaction due to the water flowing from inside, right. As you can see, the water that the liquid that flows from down to left in this particular case is changing in its momentum, the direction of this is changing, and therefore there is a change in momentum which will lead to two sets of forces, one on this surface and the other on this surface. Okay. I could either show it to be an interaction over this entire stuff as something like this and call it as say R, or I can choose every single point. Okay. In this particular case I have just chosen to represent it using R. This is due to change of momentum of the liquid flowing. Okay. Now this liquid could also, while it is flowing, could have resistance on the walls, okay, and therefore it could also create some kind of friction or the boundary layer friction on this set of walls, and therefore you could have drag forces of this sort created on the surface of the body. Okay. And that completes the interaction with the fluid, and therefore we have now removed all the interactions and substituted with the equivalent forces, and therefore this is the free body diagram of the pipe. Okay. And by now you are now getting familiar with how to draw the free body diagram. It is essentially looking at the interactions. There could be two interactions primarily, one that the body interacts with an external non contact source, the other is body interacting with contact at its boundary. Okay. Only those two are the ones that we are considering.